Greetings, the Astro 30 here, and welcome back to another exciting episode of Astro's Electronics Lab. Now, today's video I'm going to be looking at how do we calculate the series pass resistor or dropper resistor that is required in series with an LED when connected to a voltage supply. The reason we have a dropper resistor is because most of these LEDs run on a voltage between 2.1 and 3.2 volts depending on the LED, and obviously you cannot connect the LED directly to plus 12 volts, for instance. You'll just instantly burn it out. So there is actually a way you can calculate the resistance value required using the inverse function of
ohms. It's not just fun, it's the law.
And in order for us to do that, we need to know three things. One, the voltage requirement of the LED. Two, the current draw of the LED at that voltage. The average current draw of most generic LEDs is around 20 mA. And we also need to know what the voltage drop is going to be across this resistor. In the JCAR catalogue, in this case this is the 2018 JCAR catalogue, but I'm pretty sure the 2020 does the same thing. It gives you a table here of all the available LEDs and two of the figures that we need to know, which is the current, we'll ignore the maximum current, but the current and the voltage that the LED requires to work at. So in this calculation I'm going to do next, I'm going to use this orange diffused 20 mA at 1.9 volt. So we know the voltage is 1.9 volt and the current is 20 mA. So we now need to know what the voltage drop of this resistor is going to be. At a supply voltage, we're going to say in this instance of 12 volt. So in order to calculate the voltage drop, we just take our supply voltage, which is 12, and we minus the voltage of the LED, which is 1.9, and that gives us 10.1. So in this calculation, the voltage drop across that resistor is 10.1 volt. So now we need to use the inverse function of
Ohms.
Okay, that's getting a little lame now. We need to use the inverse function of Ohm's law, which is resistance equals voltage divided by current, which would be, in this case, 10.1 divided by 0.020, and that'll give us our resistance value. So we've already got 10.1 in there, so now all we're going to do is just divide that by 0.02, don't need the zero. We're looking at roughly 505 ohms. So our final resistor is going to be 505 ohms. Now, you can use the nearest value. In this case, we're going to go with 500 ohm. Now that we've done our calculation, they also give us the preferred resistor value over here for that LED or LEDs. So in our case, it was the orange diffused 20 mA, 1.9 volt, 30 microcandelas. Their preferred resistance value at 12 volt DC is 510 ohms. And as we can see, our calculated value was actually 505. But you could easily take it up to 510. It's usually better to increase the resistance value rather than decrease it when rounding it. But we can see that the math works. Let's try another one. Of course, this is not going to help you if you don't have access to a JCAR catalogue, but you can probably find most of these figures, like its current draw and its operating voltage, from the supplier where you buy the LEDs from. Anyhow, I'm going to take a high brightness blue LED with its maximum, well, typical current draw of 20 mA, 3.2 volt, and 6,000 microcandelas. And we're going to use the 12 volt one again, so the figure we should end up with is 430 ohm. Let's see if we're right. So, first we need to know the drop. So it's 12 minus 3.2. 12 minus 3.2 volt equals 8.8. So that equals 8.8 volt divided by 20 mA. So that's going to be, if we write it correctly, it's going to be 0.02 ohm. So then we divide that by 0.02 and we get 440 ohm. So that equals 440 ohms. And the figure that we required, according to the JCAR catalogue, was 430. So it's not far off, the math works. Now these preferred resistor values in this catalogue are only good up to 12 volt. What if we've got a voltage of like 35? Well, it's the same thing. So we know the supply voltage, which is 35. We know the supply voltage required by the LED. I'm going to use the same one, which is 3.2 volt. That gives us 31.8. So that's going to be 31.8 volts divided by 0.020. So divided by 0.02 is going to be close to 1.6K, or 1590 ohm, which is 1590 ohms. And so we pick a value closest in the available resistance range. So we'd say probably 1.8K would be close enough. So that's the easiest way to calculate the dropper resistor of an LED, so it makes the LED happy at any given supply voltage, as long as we know two things at least: the required voltage supply of the LED and the amount of current that it draws. Working out the resistive drop across this resistor is easy. As I said, it's just your supply voltage minus the required voltage for the LED. And just a quick side note, it doesn't matter where this series resistor is. It could be on the anode or the cathode. So it doesn't matter if the resistor is connected to the negative or ground or to the positive. The calculation is still the same. Anyway, I hope you found this video informative and useful, and if you did, please remember to rate, comment and subscribe below, and you can always follow me on Facebook. And you can also now support me on Patreon. Your support on Patreon will help me bring you more exciting content to this channel. So anyway, this is Yastro30 saying see ya, happy LEDs.